Welcome to the Deep Dive. This is where we tackle complex topics, dig through the sources, the articles, all the research, really, to pull out the stuff you really need to know. We want to get you up to speed, genuinely well-informed, fast. And today we are diving deep into Kubernetes namespaces. We've sifted through key material, things like Kubernetes namespaces, logical isolation for cluster management, to give you the clearest picture of this really fundamental concept. Look, namespaces aren't just some technical footnote. They're absolutely vital for organizing, for securing resources in any shared Kubernetes cluster. If you work with modern infrastructure at all, you'll want to stick around for this.
Absolutely. And, namespace might sound a bit technical, maybe a little dry even, but getting your head around it is what really makes managing a big, complex Kubernetes setup feel, well, doable. Less overwhelming, definitely. Stops you getting lost in the weeds.
Okay, so let's unpack that. When we talk about a namespace in Kubernetes,
Yeah.
who is it exactly? Are we talking like drawing lines on a map, or is it deeper than that?
Oh, it's definitely more fundamental. Think of it maybe like having separate soundproof offices in a big, noisy, open plan workspace. Each team, maybe each project, gets its own office. That's your namespace. Inside, they can arrange their stuff, their apps, their data, however they want without bothering anyone else. It's a mechanism for logical isolation, separating resources within the same physical cluster. It's like a virtual partition, right? It groups pods, services, deployments, keeps them neatly apart. And that's why names only need to be unique inside their own namespace. You could have, say, web app in namespace A and another web app in namespace B, no problem.
Okay, the soundproof office analogy helps a lot.
Yeah.
So keeping things tidy, but in a complex system like Kubernetes, tidiness isn't just about looking neat, is it? It must solve some real problems. So yeah, beyond just organization, what are the actual headaches namespaces save you from?
You're spot on. Without namespaces, honestly, a Kubernetes cluster just descends into chaos pretty quickly. They tackle several critical issues. First, like we said, isolation. They stop resource conflicts. Imagine two different teams both trying to deploy something called database service. Without namespaces, instant collision, disaster. Second, organization. They group related things together. So instead of one giant flat list of maybe thousands of components, you see logical chunks, much easier to manage. Third, resource management. This is big. You can set limits, CPU, memory, that sort of thing, per namespace. So one badly behaved app can't just hog everything and starve the other.
Yeah, it prevents the noisy neighbor problem.
Exactly. Fourth, access control. Namespaces work hand in glove with RBAC, role-based access control. This lets you say, okay, this user or this team, they can only touch things inside the specific namespace, keeps your critical production stuff safe. And finally, all this together enables multi-tenancy, letting different users, different projects share the same cluster securely without tripping over each other.
So it's really about enabling people to work independently, safely, even though they're sharing the same underlying hardware. It removes friction. You avoid those coordination nightmares, those who broke production moments. It really de-risks the whole operation. Makes you shudder to think about a big cluster without them. Okay, we've got the what and the why. Let's pull back the curtain a bit more. How do these namespaces actually work? What are the mechanics?
Well, at its heart, it's about that logical boundary we talked about, and you define it declaratively, usually in YAML. The key concept is resource scoping. Every single resource, a pod, a service, whatever, lives inside a namespace. And its name only needs to be unique within that namespace. Like we said, two pods called My App are fine if they're in different namespaces. Oh, and if you create something in it, maybe you forget to specify a namespace, Kubernetes just drops it into the default namespace.
The default namespace,
Yeah.
okay. So if I'm writing the YAML definition for a namespace itself, what's the bare minimum I actually need to put in there?
It's surprisingly simple, actually. When you define the namespace object itself, the main thing you'll care about in the YAML is the metadata section. Specifically, you need metadata.name. That's the unique name for your namespace, your virtual partition. You'll also have API version, which is usually v1, and kind, which must be namespace, the spec section. You almost never use it for namespaces themselves. It's really just about giving it a name.
Simple enough. Are there any namespaces that Kubernetes just creates automatically? Ones we should, know about?
Yeah, there are a few important built-in namespaces. Good to be aware of them. There's Kube System, that's where Kubernetes itself lives. All the control plane components, the core system services, they run in there. Generally, you don't mess with Kube System unless you really know what you're doing.
Right, hands off the vital organs.
Exactly. Then there's Kube Public. This one's for resources that need to be visible cluster-wide, maybe even readable by unauthenticated users, think like cluster information. And lastly, there's KubeNode Lease. This is more internal, used for monitoring node health, basically tracking heartbeats from each node. So yeah, while they exist as an application developer or even most admins, you're probably not directly interacting with Kube System or KubeNode Lease day to day.
Okay, so mostly background system stuff.
Sure.
Got it. Now, beyond just keeping names separate, what other, let's call them superpowers, do namespaces give us for managing clusters better?
Superpowers, I like that. Well, a big one is resource quotas. You can set hard limits on how much CPU or memory a namespace is allowed to consume, or even limits on the number of objects, like how many pods or services can exist in that namespace. This is crucial for fair resource sharing. Stops one team or project from accidentally or intentionally using up everything.
Resource fairness. Nice.
Yeah.
What else?
Network isolation. This is achieved using network policies. You can define rules that say, for example, pods in namespace frontend can talk to pods in namespace backend, but pods in dev cannot talk to pods in prod. It adds a really important layer of security, segmenting network traffic between your logical partitions.
Okay, so pulling this all together, why are these features, these distinctions, not just, nice to haves, but really crucial, especially as your cluster grows?
The practical impact is just huge. For organization, it makes managing complex clusters so much simpler. Grouping by team, by project, by environment like dev, staging, prod. It brings order to potential chaos. It transforms this potentially massive, flat list of things into a structure you can actually navigate and understand. For isolation, like we stressed, it stops those naming collisions. But more importantly, it reduces the risk of, say, a bad deployment in one area affecting something critical elsewhere. Think about the stability that brings. Knowing your test environment screw-up can't take down production, that's a massive peace of mind.
Yeah, it definitely helps you sleep at night.
Right. Then there's access control. Tying RBAC to namespaces means really fine-grained permissions. You can lock things down so developers only have access to their development namespaces. SecOps might be the only ones who can touch production. That's vital for security, for compliance. And finally, resource efficiency. Using those resource quotas prevents any one namespace from hogging resources. It ensures fairness and that critical apps get what they need.
It really is like building separate, secure lanes on the same highway, isn't it?
Yeah.
Let's make this more concrete. Can you walk us through some real-world scenarios where you'd heavily rely on namespace?
So, absolutely. They're super versatile. A classic example, multi-team environments. So you have several development teams sharing one cluster. You give team A their team a namespace, team B gets team B, and so on. Each team manages their own applications, deployment, services within their namespace, no stepping on toes, and you apply RBAC, so team A literally cannot modify team B's resources.
So if someone from team A tried to deploy into team B's space by mistake, what happens? Just an error.
Exactly that. The Kubernetes API server would just reject the request. First, they likely wouldn't have the permissions via RBAC, and second, even if they did somehow, the name they're trying to use might already be taken within Team B's namespace. The system enforces the boundary. Another huge one is environment separation, using namespaces for dev, staging, prod, all within the same cluster. This is incredibly common and powerful. Your experimental stuff in dev is completely walled off from your live customer-facing services in prod. Development mistakes stay safely sandboxed. They can't impact production.
Makes total sense. And how does this tie into managing resources and security more broadly in those scenarios?
Well, for resource management, imagine you have a batch processing job that's important but not super time critical. You could put it in its own namespace with a fairly strict resource quota, limiting its CPU and memory. This guarantees it won't subtly consume tons of resources and impact your main web applications, which might live in a different namespace with more generous quotas. And for security and access control, it's fundamental, like the RBAC example. Developers get full control in dev, maybe read-only in staging, and absolutely no access, not even visibility, into prod. You limit permissions to only what's necessary for each role in each specific namespace. That drastically reduces the attack surface and the potential for accidental damage.
It really sounds like namespaces are woven right into Kubernetes DNA. How does Kubernetes actually enforce all this? Is it mainly the API server acting like a bouncer?
That's a great way to put it. The API server is the central gatekeeper, the bouncer, yeah. When you submit a YAML file defining a namespace, the API server validates it and stores it in etc., which is Kubernetes Brain, its distributed database. Then, whenever you try to create any other resource, a pod, service, config map, whatever you put metadata.namespace in its YAML, the API server checks that field. It verifies the namespace exists and, crucially, checks if you, based on your authentication and RBAC rules, have permission to create that resource in that namespace.
So the check happens right at the entry point.
Exactly, and it doesn't stop there. All the other core Kubernetes components respect these boundaries too. The controller manager, making sure reality matches your desired state, the scheduler, deciding which node a pod runs on, kube proxy, handling network rules. They all operate within the context of namespaces. They query the API server for objects within specific namespaces. RBAC policies are constantly evaluated by the API server on every request. So yes, it's deeply integrated. And then for users, tools like kubectl make it easy to interact. You just add "and" your namespace to most commands to target a specific one.
That's super clear. Thank you. Okay, to wrap up the how-to part, what are the key best practices people should really take away if they're starting out or just want to clean things up?
Good question. A few key things come to mind. First, use descriptive names. Don't call them NS1, NS2. Use names like team billing, prod frontend, monitoring. Make it obvious what's inside. Future you will thank you. Second, definitely apply resource quotas. Don't skip this. It's your safety net against resource exhaustion. Start with something reasonable and adjust. Third, implement RBAC. Seriously. Lock down permissions. Least privilege is the goal. Grant access to namespaces only as needed.
So don't give everyone cluster admin rights.
Please don't. Fourth, try to avoid the default namespace for your real applications. Keep default for quick tests maybe, but create specific named namespaces for actual workloads. It forces better organization. And finally, version control your YAML. Store your namespace definitions, your quotas, your RBAC rules, everything in Git or a similar system. This gives you history, allows for review, makes deployments repeatable. Infrastructure as code applies here too.
Great tips. Be intentional, set clear boundaries, use access control, and track everything. So really, what we've uncovered today is that namespaces aren't just a handy feature. They're absolutely fundamental. They're the key to building Kubernetes environments that could actually scale, that are secure, that are manageable day to day, that bring essential order to what could otherwise be, well, just a big jumble of pods and services.
Yeah.
They let teams and apps coexist effectively.
Exactly. And understanding this, really getting it, it equips you to navigate these sometimes complex Kubernetes environments with a lot more confidence. It helps you get truly well-informed quickly, cutting through some of the noise.
Definitely. So here's a final thought for you, our listener, to chew on. Thinking beyond Kubernetes in your own work, maybe your personal projects, even just organizing your life. Where could applying a similar principle of logical isolation, creating those clear boundary or those dedicated spaces, bring similar benefits? Where could it improve clarity, control, or maybe even prevent some unexpected collisions? Something to think about. Thanks for joining us on this deep dive into Kubernetes namespaces. We'll catch you next time.